Okay, previous class we stopped at example 5. Okay, recall what is principle of impulse and momentum. What is impulse? Nicole, what is impulse? Tom, what is impulse? Huh? What? Tom, what is impulse? 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 Integrate force. What? Force and what? dt equal. What is momentum? No. Momentum, mv. Okay, so impulse, in principle of impulse and momentum is your impulse will equal to the change of momentum. So mv1 minus mv2. What? What are you asking? Yeah. So what do you understand about on the right hand side? What do I write? Okay. Remember, it's important. Getting more and more important if you go into rigid body later. Impulse is force and time. Force multiple by time to get your impulse. So how you memorize, you can memorize the unit Newton over second. Oh, sorry, Newton second is your impulse. Momentum is mv. What is momentum? Momentum is m as kilogram, meter over second. Kilogram second. So okay, later we do the conversion. Okay, let's look at another example, example 6. You have do piling and there's a hammer and a pile, right? Pile P, the vertical body, P is go inside the sand, and before the hammer hit the piling, there's an initial height of 0.5 meter, and you're given a datum. When you see question with datum, what type of question only have datum? The only two. The only two kind of question have datum. Pulley system and what? Pulley you always see datum. Correct. Right. Yes. What is potential energy? mgh or v. So when your datum is given, on top of datum give you positive v, below datum give you negative potential energy. If you see the question have datum, it's not pulley. If it's not pulley, then it's fall under this category. When you see this one, what equation involved with energy? There's one what? Conservation of energy. What is conservation of energy? Huh? Now give me a general definition. What is conservation of energy? What before equal to what before? Conservation of energy deal with what? Energy, right? So what before equal to after? Okay. Change of energy equal to change of after. So far, 2. So kinetic energy plus potential equal to kinetic plus potential. All these are 3 marks. Here 2, already 4 marks already. So you read the question, you're given a mass. Mass of pile is given, driven into the ground using hammer 300 kilogram. Hammer fall from rest. The initial velocity was given. Height initial was given. Strike top of the pile. Determine the impulse with the pile exerted on the hammer if the pile is surrounded entirely by loose sand so that after striking the hammer does not rebound from the pile. So, and from the impulse, principle of impulse of momentum, there's one more, conservation of momentum. Conservation of momentum. What I mean by conservation of momentum? You focus on what? Huh? Give me a more general explanation. Conservation of energy, you focus on energy. Energy before equal to energy after. Conservation of momentum, you focus on momentum. Momentum before equal to momentum after. Right? MV1, MV2. Okay, this is one body. If two body, you have 2 scenario. After hit, join together. After hit, bounce back. So you have 2 equation. M1, V1, M plus M2, V2 equal. If separate, you have 2 body, what? M1, V2 plus M2, V2. Okay, or M12, M22, because different velocity. If you coupled, join together, what you get? M1, V1, M2, V2 equal. When you join together, what happened to the mass? Huh? When you coupled, join together, what happened to the mass? How come same? You have 1 kilo, 2 kilo, you join together. You have the total mass. Then V same. Okay? This is called conservation of momentum. Okay. So when you look at the question, basically you can write out all the equation already. For example 2. Although it look very complex, you look at the question, you're giving datum, you think, what kind of question have datum? Pulley and potential energy. When you deal with potential energy, you deal with conservation of energy. You write lah, conservation of energy. T kinetic plus potential before equal to kinetic plus potential after. You show or use this one. Then you slowly analyze the question. Then it give you, the question give you, find the impulse. There's only one equation deal with impulse, with the principle of impulse and momentum. So impulse equal to the change of momentum. Then you rewrite M1 V1 plus integration of F dt equal to MV2. Or you can write this one on the whiteboard. Like what? Same. Right? Then once you have this one, and this one was 2 bodies bang together, so conservation of momentum happen. So M1 V1 plus MV2, it depends on 2 object or single object. This one after it hit, what happened? Separate or coupled? Have you go to construction site? Never. You never see this machine before. You don't know what is this? Huh? You don't know. You haven't seen this one. When people build building, they do piling. After it hit, will it join together? Yeah, after hit, will we join together or not? Will we like hit and then join and then pull the power out? How? After hit, then what? H will go back, what? Then this one will go in, what? It's like hitting a hammer and a nail, what? So if you say coupled means you hit hammer with the nail will fall, will glue to the hammer, and then you pull out. Then they lost the purpose of doing hammering, ma. This is a simple logic, simple logic. You look at the process. After it hit, separate, then you use the second equation, conserve momentum. This one. Very easy one for engine dynamics, very easy one. You look at the question, you try to think, what I need to find. Then only a few equations to choose only. And then the question, we purposely designed to confuse you one. So confuse yourself with chapter 1, chapter 2, chapter 3, chapter 4. Basically, each chapter have their own equation one. For example, chapter 4, you deal with impulse. And then the question already give you to find impulse. It is chapter 4 question. So chapter 4 only have principle of impulse and momentum. Then it deal with what? And then it give you a datum. It already leak the question to you already. Give you datum. Datum only have two scenarios so far. Pulley or or potential. So you use the potential. Potential is what? Energy. So conservation of energy before equal to after. So you write T plus potential before equal to after. And then you wait. Then you continue to read. So you expand all this question. T is what? What is kinetic? You expand into half mv square. You write then this one mgh. Then same. Then here, you also can write m1 given, v1 given, m2 given, vu2 given. Then the rest you don't know. Okay. Then you need to ask yourself when you need to use conservation of momentum. When you look at big picture, you want to look at before and after. You don't want to know what happened in between. Meaning you want to know before you have mass before, velocity before, and you only interested in what happened after. Velocity after object 1 and object 2. Then you use conservation of momentum. Then you want to know object 1 move how fast. You want to look at the process already. Then you use principle of impulse momentum for that body. You see the picture or not? I hope you see the picture first. You have to understand when I use this formula, when I use that formula. Okay. So principle of impulse momentum, you only look at that particular item. Then you find the velocity before and after. This one is individual object, principle of impulse momentum. Okay, so let's dissect the question. You draw free body diagram. So it tells you the hammer does not rebound off the pole. It means we only interested at the time it's and then stop there. You pause the time. So you draw the free body diagram like you see on the screen here. You see two red arrow. Don't confuse by two arrow. The chocolate color hammer, what does it feel when it hit the pole? You feel the force punching into the body of hammer or pulling out from the hammer when it hit the pole? Force go in or go out? Go in, go into the body. So the bottom arrow refer to the chocolate. Don't confuse with the arrow. The bottom red arrow is referring to hammer. The top arrow is referring to the pole. Because the pole also feel that the force going into the body. Don't confuse. So you have, in this case, I do not use F, I use R to represent force. Of course, in the exam, you can use force. You can use capital F, no problem. In this case, I use R to represent force. And in this case, where is your direction? Positive go where? Go up or go down? Positive. Huh? Go up, go down? I use the normal X and Y. Datum go up positive, go down negative. So you use one set of datum. Huh? Means you look at datum. If arrow do not given, then you decide. I will always use the conventional one. If datum given, direction or not given, I follow Y positive go up. So in this case, you see R pointing up is positive. R pointing down is negative. Okay, my Y, my Y, I should be, okay, in this case, on my slide, I should flip my Y go up. Wrong notation. I should flip my Y go up. Because if I point down, then the direction is wrong already. My notation for my force is wrong. Okay, my slides, my Y should be go up positive. So then the soil force is 0 because it say surrounded by loose sand. Loose sand means it can absorb all the force. Right? So no sand force here. And the weight of the pile also 0. Okay. Weight of the hammer and pile and the resistance force of the sand are all non-impulsive. Why? Why non-impulsive? What is impulse? Force times time. So just remember, this one is a non-impulsive. Momentum is conserved. Repulsive. Okay. Inside here, it cancel when you look at big picture. Okay. So we use conservation of momentum. Momentum before equal to momentum after. Make sense, the equation? Then your velocity, number 2. Okay, you change your A to V to hammer and pow. My hammer is A, pow is B. Or in your answer, make sure you label. Don't give me empty free body diagram, and then you suddenly write A and B. I will put question mark. What is A? What is B? Go and label. If hammer is A, you write A. Pow is B, then you write B. Okay. Or you can label hammer, then H, then MH. Okay. Then you substitute, you get your velocity number 2. Okay. Now, conservation of momentum, you look at big picture, what happened before, what happened after. Normally, what you can find is the velocity. Once you have velocity number 2, you're able to find, you're able to use principle of impulse and momentum. Now, just now, I explained when do you use impulse and momentum. Principle of impulse and momentum, you look at individual body. You zoom inside individual body, and then you freeze the time. So, you look at hammer. Hammer, the weight of the hammer we ignore, and the resistance is go inside there. Is hitting, hammer hitting the pile, the pile will have a force pointing into the body of the hammer. All right. So, free body diagram, you write principle of impulse and momentum, momentum before plus impulse plus momentum. Okay. So you already have V2 just now. M2 you can find. Then MA you can find, given what is MVA before it hit, what is hammer velocity? Before hitting y0. Which statement tell you is 0? Yeah, the hammer fall from rest. So this one 0. Okay, what are the force you have? Okay, so here it fall from rest, VA. Okay, conservation, you use energy. So energy, kinetic plus potential, before equal to after. So MVH hammer plus potential energy hammer. Again, when you do at energy, you look at that body only also. You don't mix two body. You don't make yourself confused. You focus on that body, then you do conservation of energy. Okay. So here, hammer, 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 hammer. You substitute, you only have velocity of your hammer. Okay, this is after. You want to hammer, you want to find velocity after, right? So here, okay. So V1, V2, they are looking at just before hitting the sand, the pile, not from the top. Is look at that particular time hit before and after. Okay, that's why you find V1 and V2. Try to observe the solution. Try to observe when we see the big picture, when we see the narrow picture. Okay. Then you find the VA1. Just now, this one is not 0. 0 is far before, but when you do principle of impulse momentum, you're looking at just before the body hit. And what does the principle of impulse of momentum do? It do with collision. Okay, you look at that particular moment, you freeze the time, and at the moment you meet together. So that's why your VA1 is not 0. It's 0 when you look at bigger picture, before and after, then 0. When you look at the process, then it's not 0. It's before it hit means it have a velocity. So that's why you VA1, there's a value there and not 0. Okay. You do integrate, you find your impulse. Right? This is the impulse the answer want you to find. Right? The question want you to find. Okay. Question? No. Now we zoom into impact. Just now collision also impact, but now we look at particle impact. There are few motion or process that involve with impact. So there are two types of impact, or there are two types of collision. One is called central impact, where the two bodies collide in the line of impact. We mean on a straight line or on the flat body, move and then then meet together. It's called central impact. So V A refer to A, B, and refer to B. The another type of impact is called oblique impact. Okay, impact is like you playing snooker. You come with a different angle but meet at the one point is called plane of contact. Both diagram also show you plane of contact. Huh? So the first one, central impact come in the same line or parallel. This come in the same line, hit together. Oblique come with a different angle, but meet at plane of contact. And the angle of coming in refer to the line of impact. What is the relationship between plane and line? 90 degree. Huh? So don't say, Dr. Ang, I don't know how to draw. They always have a plane of contact, then you draw line of impact, then given the angle. Okay, so let's look at central impact. Central impact, let's say you have two body, VA, VB, but VA is faster than B. Both moving, but A is faster, so A going to hit B, right? So here you have two body, conservation of momentum, MB, MV. You want to look at big picture, huh? So then when it bang, it called deformation phase. You will bang, it will squeeze, the two body will squeeze. So when it bang, remember, you imagine yourself at that particle and what do you feel? If you're A, the force is pointing into your body, right? If you are B, the force also pointing into the body. So don't confuse by the positive P and negative P. Yeah? Negative P referring to A, positive P referring to B. Yeah? And from this diagram, positive direction in my class, I always follow the higher velocity. Positive direction always follow the higher velocity. For example, A faster than B, moving to the right. So my positive direction is positive to the right. In this case, you see negative P and positive P. And you know, when two bodies meet together, it involves with impulse. So impulse give you one equation, principle of impulse and momentum. So integration of F dt equal to mv2, mv1 minus mv2 minus mv1. Okay. So when they meet, there is an impulse. Then they squeeze and coupled together, move at the same velocity. So this is maximum deformation. This is coupled. So if you look at this kind of question, you remember, if you look at bigger picture before and after, you use conservation of momentum. Momentum before equal to momentum after. But the one I write on the whiteboard. We have two momentum, then one momentum. This one join with the mass. Okay. Then if you want to look at individual, what happened, the force happened on the body of that particular individual particles, you focus on the impulse. Which means you pull up principle of impulse and momentum, and then only look at that particles. Here you have two impulse. Impulse A, impulse B. But you combine, you won't see the effect. It will give you conservation of momentum. Okay? So, can try to understand when we use the equation. Then, after deformation, something will happen. After deformation, they will split away. Because we're dealing with particles. After maximum deformation, it do not join together, but it will deform maximum, and then it will repel. We are talking about elastic body. The maximum deformation, then it will repel. When it repel, look at the diagram. When you repel, same. This is effect of A on B, same. Huh? The force will also pointing different direction. Okay, pointing direction. Okay. Then the name is called restitution impulse. Okay, nah? Before this, before it's squeezed together, the name is called deformation. After maximum deformation is start to bounce back, is called restitution. There are two processes. Huh? One is you look at the point of maximum deformation. The one before is called deformation. The one that after deformation is called restitution. Then it's split together. Then it's split away. Okay, restitution here is either return to their original shape or permanently deformed. There are two scenarios. Huh? Then after impact, they will separate. There are two cases. Either velocity B will become faster, B slower, or B slower, A faster. In this case, B will move faster than B. It's like snooker. You knock, then another door will move faster. This is after impact. So MV2 will higher than MV1. Oh, sorry, momentum B will be higher than momentum A. Makes sense? Makes sense?
But always B is faster than A. Then how like possible for it?
B is faster than A. You cannot imagine. Have you played snooker before?
Faster than B.
A faster than B. Okay, that case, you imagine you have two body, different mass. Different mass, A, B, different mass. Then there's a possibility A move faster than B. If B is heavier, right? You have a fat man and a small man, you hit. It's like a children hit the adults. The kids will bounce back a lot, right? So A will faster than B. Okay, but different direction maybe, right? So you understand the process, right? Then there's a calculation there. So if you look at big picture, momentum before impact and after impact, you use conservation of momentum. Just now we have a series of incident, right? Before and then deformation, maximum deformation, and then split. This one, you look at before and after splitting. Before, after. Then you use conservation of momentum. You don't care what happened between the process. Okay. Then to obtain the forces and also on, you use principle of impulse and momentum. This one is during deformation case. For example, A and B, before impact and deformation. This is before maximum deformation, which is the first section of the movement. Then you use principle of impulse, right? Principle of impulse and momentum. Okay, mv minus force time into impulse, y negative on A. Direction positive is to the left or right? Right. And then the force feel by the body is what? Go inside, so it's opposite direction. So it's minus P and not positive. Okay, do the same for B. Okay, this is deformation. P. After maximum deformation, the phase is called restitution, which is it start to restore the shape. After compress, it start to restore the shape and then separate. So restitution, same, but we are use minus R. Why minus R? Because the force is also pointing in. Okay, so still pointing in. This before split lah. You still feel that the body is still being pressed. Okay. So you have two formula on the screen here. One is deformation, one is restitution. Try to understand what is restitution, what is deformation. You combine, you get one new equation you learned today, which is called coefficient of restitution E. You take restitution impulse divided by deformation. Restitution divided by deformation. Okay, restitution divided by deformation. Okay, this is, or you can remember after divided by before. Or output, input, same. Okay, you put in the equation. This is restitution impulse integration R dt. Deformation impulse is integrate P dt. You this one to the, you move this one to the right. You have MAV A1 minus MAV. This one MAV minus MAV A2. You get positive. MAV plus MAV A2 equal to integrate RT. Make sense? Then you put inside this equation, cancel the mass. You get V minus VA2 divided by VA1 minus V. Makes sense? This is for A. What happened to B? For B, you repeat the same process. You'll get VB2 minus V divided by V minus VB1. You have A and B, equation 1, equation 2. You eliminate the V, okay, by simultaneous equation. You arrive at one equation that link body 1 and body 2. Restitution equal to B2 minus VB2 minus VA2, VA1 minus VB1. How I remember? The top is after, below is before. I deal with velocity. I always take positive value, high value minus low value. Same with bottom. Bottom velocity A before always higher than B, so I pick higher minus low value. This is how I memorize. Okay. So VB2 minus VA1 also relative velocity. When it comes to final exam, you are no longer given velocity, but you will be given relative velocity. You still remember I write VA over B? Velocity A subject to B or A relative to B. You can write VA minus VB. Or in this case, is BA equal to VB minus VA. In exam, you'll be given this one and not this one. You won't see velocity A, velocity B anymore. Okay, so don't confuse when it comes to final exam. All right. You have two types of value. When it comes to final exam, you'll be given two cases. One is elastic impact and plastic impact. So elastic impact means this is 1. So this one you pull to here, you get left hand side equal to right hand side. Okay, when it's plastic or inelastic, then you get 0. You get 0 here. Okay, it means we couple or stick together, then you get plastic impact. This one 0. Okay, here you get 0. You move to here, you get 0, right? Okay, same. Just now, conservation of momentum. Then you get the restitution constant. You have VA, VB, VA, VB here. You can solve. You can solve using this equation into here. Okay, so when you learn about this one, the question in the assessment will change a little bit, where you'll be given one more constant is called restitution constant that give you this equation. But question won't give you the equation. You have to memorize. Okay. We have done with the central impact. Now we deal with oblique impact. Oblique impact, again, two body come in the different angle. It gives you 4 more unknown you need to solve. Theta 2, velocity 2, phi 2, and velocity b2. You need to find these 4 unknown. And how you find these 4 unknown? You need to break all your free body diagram into x direction and y direction. You break x and y, you solve, then you get velocity in x, velocity in y, you find the resultant back. Okay, then you find the angle. Angle equal to inverse of your tan angle. You find your Vx, Vy for B, you find resultant, square this one plus square this one, square root, you get the resultant. How you find angle? Tangent y divided by x. You do for B, you do for A. Okay, this is the strategy when you solve oblique impact question. You see oblique impact question, you look at the axis, it give you x and y, split into x and y, focus on x, do your calculation, focus on y, do your calculation. This one only, and you see the line of impact, or you see oblique impact, impact the word also tell you you need to use equation of principle of impulse and momentum. Meaning you break this equation of impulse and momentum into x-axis, y-axis for one body. If you see 2, means you have 4 equations. Make sense? Okay. Break into something like you see on the screen here. X direction, Y direction. And this one is for X direction only. X and Y direction. Okay, for A body, B body. Then your solution, you only look at X, one set, look at Y, one set, same with A and B. Yeah, you are using principle of impulse and momentum. So for your Y, you won't see impulse because your Y don't have X direction for impulse. Same with this one. Great. Let's do example 7, then we call it a day. Example 7, you look at the diagram. There's one bag A, bank B, tied with a rope. What kind of motion you have? Linear or collinear? Collinear. Why? You tie to a rope, you swing, you get the collinear motion. Collinear motion, straight away on the free body diagram, you draw what? All tangent and normal axis. Then from there also, Every time you have a collinear motion, after you draw normal tangent, what equation you write? Acceleration, you can break into tangent direction and normal direction. What is tangent acceleration? Huh? Dot V or dV dt. What is acceleration in normal? V square over rho. And this one is tangent velocity. So there's an equation to find the rho, right? 1 plus something. Then this one plus d. In this case, the rho is given, so you don't need to use this equation. Unless the question change this one to elastic. Okay, but that one is another case. Okay, this one don't have elastic. So bag A given mass 3 kilogram, released from rest, position 0. After falling to 90 degrees, so this one is anti-clockwise direction, positive. Strike 9 kilogram box B if the coefficient of restitution is given. Meaning you write this equation on your answer sheet. Equation restitution constant equal to VB2 minus VA2 divided by VA1 minus VB1. Given, determine velocity of the bag and the box just after impact. What is the loss of energy during collision? Again here, you look at the question, it tells you the velocity, body, and there's an impact. Give you line of impact. So there's only two equations, not two, but there are few equations they can use. You have line of impact, it means principle of impulse and momentum you need to use. Then there you have two types of impact, right? Central and oblique. This is central or oblique? You look at before it hit the B. What is the motion? What is the direction of? This is B. This is A. This is collinear motion. Collinear motion at this point, what is the direction? This is central impact. Because they hit at the line of impact. Although this one come by a certain angle, but this is a curve. Curve always moving in the tangent direction. Okay. So this is central impact. So I draw the free body diagram. I focus on A. My datum, I refer to the top. Although the question do not give me datum, the question asks loss of energy. You see the word energy, you use conservation of energy. What is conservation of energy? What is conservation of energy? What before? Energy before equal to energy after. Write that one. So datum, in this case, I go down for datum is on the top, so go down will be negative. Okay, I label O and 1, and my mg point down, mg point down. Yeah. Don't make these mistakes in your test one. Don't draw something like this. Don't draw this one. If you draw this one, I'm going to expose your answer to the whole school. I'm not kidding. I'm going to expose this one to the whole school. I'm going to share with all lecturers. Okay, so we have a W only. This W only. Okay, you use conservation of energy. So kinetic plus potential before equal to after. What is the kinetic energy before? Huh? Half mv square equal to, what is the velocity before? 0. So velocity equal 0. What is the potential energy before? mgh. So what is the h? Before 0. H is 0 here. Then after mv2, mv1 is here, velocity at here. You need to find the velocity before heat. The energy, potential energy, mgh, h is -1. In this case, go down negative. So in this case, my answer is wrong, because for the second half, I should write negative WH1 and not positive. There is an error in my calculation. So you put in the answer before 0, 0, after mv square, and my h should be negative. So my velocity A will be positive value. Okay. If you do the same mistake like I do on the slide here, you get negative sign. It means it bounced back, which is wrong. Yeah, be careful on the direction of your datum. On below the datum is negative. So you get your VA1. You look just before the impact. You use conservation of moment. Means two body before impact, you freeze the time. Then you use before and after, conservation of moment. Okay. So you have just before and just after. Okay. Now just before, the BV1 do not move. So 0. A you find just now. It should be moving this way. If you get negative, means wrong. Means it's go this way. It's wrong. Right? Just after, this one move with one speed, this one move with one speed, and not same speed. Okay. And don't go and do coupled case. Because the question do not mention coupled, so don't do coupled. You do coupled, only question mention coupled together. Then only you do coupled equation. Yeah. You write the conservation of momentum, mv before equal to mv after. We have two bodies, so mv1, mv2. Okay. You substitute, you get velocity. First equation, you have two unknown. You cannot solve. You need one more equation. All right. You call equation of restitution constant. You call that one because after collision, B2 move faster than VB2. Okay, so you can use this one. This one is, you derive this equation is because the VB2 faster than A. Then you use this one. But if VB slower than A, you cannot use this one. You need to derive from the original equation. Don't assume this one always work. You need to work carefully, look carefully. Does the object move slower or faster? This case, VB will move faster than B. Okay? We assume, we assume in this case, we assume. So that's why you can use this case. We assume. Okay. So you assume this case, but you find negative answer, then your assumption is wrong. Okay. You substitute, you get second linear equation. Solve simultaneous equation, you get VA2, VB2. Makes sense. Okay. Once you find VA2, VB2, then loss of energy, you use the Uh, principle of work and energy. This one come out in your coming test one. Huh? So you use principle of work to solve because there's a loss of energy here. So work done, you substitute the value. Why the t before missing one? Why? 0 for what? For A. A do not move. Okay. Then you solve. The work is the loss of energy also means work. Okay. Another meaning of loss of energy in the question you see it means ask you to calculate work. Minus 16.6 joule. Okay. So energy loss is because inelastic deformation during collision. Okay, we stop here. We continue next lecture for example B.